Okay, in this video we're going to cover the 4.5 worksheet. Make sure to have your unit circle reference sheet with you. Let's start with number 1. We are graphing a basic function of sine or cosine. Okay. The first thing you're going to do is look at it and you're going to go ahead and determine what our A is. In this case, A is 5/2. Cosine, you're going to start at the top or you're going to start at the bottom. Because the A is a positive value, we're starting at the top. Okay. First thing I did here is go ahead and draw the top portion and the bottom portion. Since there's no other numbers here, it's going to be, the origin will be at the center. Okay. So I start at the top. There's no stretching or shrinking, so we're going to use a section, a period of 2 pi and a section of pi/2. That's just like our unit circle. So remember, we have 4 sections and we have 5 numbers. Okay, we're going to start at 0, pi/2, pi, 3 pi/2, and then 2 pi once we complete that rotation. So all I did here was mark our main points, 1, 2, 3, 4, 5, starting at the top, go to the center, bottom, center, top. So one complete rotation will take those 5 numbers. Okay, then I just completely finished the rest of the graph. Okay. For 2, we are going to be graphing a function that now has a b. The previous one just had an a, now we're going to have a b. So because there's no number in front of this function here, it means a is equal to 1. So that's the first thing I did, was draw my top and draw my bottom, +1, -1. And then I see it starts at sine. Sine is always going to start in the center, but I have to determine if it's going to go up or if it's going to go down. Because our value of our trig function is positive, we're going to be going in an up direction. Okay, so that's the second thing I did. Now I'm going to look at my period. My period for a sine function and a cosine function are both 2 pi/b. Because there's a number here, that's what our b is. Here I just did the math, and I found out the period is going to be 8 pi/3. Okay. Next thing I'm going to do is take that 8 pi/3 and divide it by 4 so I can cut up my sections. I get 2 pi/3. So every one of these major marks is 2 pi/3. Okay. Since there's no phase shift or horizontal shift, we're starting our function at 0, and then I'm going to be adding the 2 pi/3. So plus 2/3 pi plus 2/3 pi is 4/3. 2 plus 4 is 6. 6 plus 2 is 8. So there I have my 5 numbers. All I did was go ahead and mark them on the graph. I have 1, 2, 3, 4, 5, and then I drew a couple more extra after that. Okay, right? Because of our graph the way it is, if you look here, you can see that the pi is right here. So the easiest way to do that is count how many lines you have between 0 and pi. Here I have 1, 2, 3, 4, 5, 6. Since I have 6 lines, I'm going to use a common denominator of 6. That means every 4, I'm going to go and draw a major point. So starting here, 1, 2, 3, 4, major point. 1, 2, 3, 4, major point. 4 plus 4 is 8. Plus 4, 1, 2, 3, 4, there's our next major point, and so forth. Okay. So if we start at the center, we're going to the top, center, bottom, center, and then I did a few more. Okay, next one, number 3. Here we're adding a shift. We're adding a letter D on here. Here's our equation. Looking at our equation, A is going to be 1. Sine, you always start in the center because the number 1 is a positive in our equation. We're going to be going up. There is no b, so our period is going to be 2 pi, and our sections will be pi/2. So we're going to be using those 5 major points on the unit circle, starting in the center, then going up. 1, 2, 3, 4, 5. The only thing is, you have to remember to go up 3. So from our origin, you're going to go up 3. That will be the center. Then you're going to go up 1, and then down 1. That will be our A. Draw your major points along the center line, and then alternate. Middle, top, middle, bottom, middle, top, and so forth. Okay, number 4, we're going to have a horizontal shift this time. So all I'm going to do is write down my main points. A here is going to be a 1. We're using a sine function, so we're going to start in the center. Okay, and then because this is positive 1, we're going to be going up. Okay. Notice that B is a 1, so our period is going to stay as 2 pi. Then we're going to cut that up and use pi over 2 or 2 pi over 4. The reason I did 2 pi over 4 is because our shift is pi over 4. Okay? The negative means that you're going forward pi over 4. So if you look here, I went forward, and this is going to be pi over 4. So that's where I'm starting, and then I'm going to be adding 2 pi over 4. So 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. Mark those points on your major line, and then go ahead and start by your forward shift. Then go up, middle, down, middle, up, and so forth. Okay, next problem is number 5. We have 2 cosine x plus pi over 3. We're sketching, so A is going to be 2. Cosine means you start at either the top or at the bottom. Because the 2 is positive, we're going to start at the top. Okay. The B is equal to 1 here, so our period is still going to be 2 pi. So we're going to use pi over 2 for our sections. That's what we're going to be adding to our numbers. Now, here is our phase shift. Now, anytime it's inside the parentheses, it's going to be a shift to the left or shift to the right. If this was a plus without the parentheses, then that tells us it's a vertical shift, either up for a positive or down for a negative. So our first starting point is going to be at negative pi over 3. I know it says positive, but remember our transformations. Anytime you have a plus, it's not going forward, it's actually going back. So over here, I ended up saying 6 is a common denominator. So I changed pi over 2 to 3 pi over 6, and I changed negative pi over 3 to negative 2 pi over 6. So now I'm going to be adding these two numbers. Negative 2 plus 3, that's a positive 1. 1 plus 3 is a 4. 4 plus 3, 7. 7 plus 3 is 10. So I made my marks here. Okay. Started at the top, right at our first point. So our first point here is negative 2 pi over 6, which is here. Start at the top, and then go to the next one, center, next one, bottom, center, top, center, bottom, center, top, and center. Okay, so you're just going to repeat that pattern. Okay, for number 6, here's our equation. I'm going to start with our A. Our A is equal to 3. Because we're using cosine, it's going to be either at the top or at the bottom. Because there's a negative in front of the 3, we're starting at the bottom. Okay. We have a B here, so I find my period first. Period is 2 pi over B. Substitute the 3/2. Do the math, and you should get a period of 4 pi over 3. That's going to be the distance for one complete rotation. Okay. Cut that period up into 4 parts, and that will give us our sections that we're going to be adding to our first point. Since there's no shift, phase shift here, our first point is going to start at 0, and all I'm doing is adding pi over 3. So I get pi over 3, 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. Mark your points on the graph, and then you're starting at the bottom here at 0, center, top. Center, bottom. Remember, the distance of A is from the center to the top line, which would be 3, and from the center to the bottom line, which is also 3. Okay, next problem. Right, here's number 7. It says graph the function, and then here we have everything. We have an A, we have a B, and we also have a C. So we're going to graph. So let's start off with our A. A is going to be the 5/2. Sine always starts in the center. Because it's a positive 3/2, we're going to go up. Okay. The other thing I did here was I went ahead and factored out the 3/2 in this equation, so that way it's easier to determine what our phase shift is. Okay, so all you're going to do is take this number and divide it by the 3/2, and here I'm going to get 1/3. Okay, now I'm going to take the period, divide it by b, which is the number in front of the x, do the math, you get 4 pi over 3, and then divide that sections up into 4 pieces, and you get pi over 3. Okay, we do have that phase shift of pi over 3, but it's positive, so actually we're going back. So we're going to start at negative pi over 3. We start in the center, which is this point here, then we go up. Okay, so we're going to do is add this to this, you get 0, which is this next point. Then you're going to add pi over 3, you get pi over 3, that's the next point. 1 plus 1 is 2, 2 plus 1 is 3. So I continue my graph like that. Number 8 says to graph this function. Let's go ahead and break it down. A is going to be 1/2. Sine always starts in the center. Because it's a negative 1/2, you're going to go down from the center. Okay. This plus 2 is going to be our vertical shift. So what we're going to do is we're going to start our center at 2, and then we're going to add 1/2 from this point. We're going to go up 1/2, and we're going to go down 1/2. That's going to be our A. So the first thing I would do here is draw out the center, the top, and the bottom. Okay. Next thing I'm going to do is go ahead and figure out what the period is. Period is 2 pi over b. B is 2/3. Solve for it, and I get 3 pi. I'm going to take 3 pi to get to 1 complete rotation. 3 pi over 4, that will be our sections. Since there is no phase shift, we're going to start at 0, and then we're just going to add 3 pi over 4 to get our next line. So this plus this is 6. 6 plus 3 is 9. 9 plus 3 is 12. So then I mark out all my points, and then I'm able to do center, bottom, center, top, center, bottom, center, and so forth. Okay. Let's go ahead and do number 9. Number 9 just says find the amplitude and the period of the function. Amplitude is always going to be the positive value, so here it's going to be 1/2. The period is going to be 2 pi over b. For sine, you use 2 pi over b. B is pi over 4. If you do the math, you find the period to be 8. Okay, number 10, we're going to find the amplitude, the period, and the phase shift of this problem. Our amplitude is going to be the number before the trig function. In this case, it's 1. Do not include that negative. That's reflection. Okay, and then to find the shift in the period, we need to go ahead and factor this 2 out. When I factor the 2 out, I get 2 parentheses x plus pi over 6. If I factor this back in, I get 2x, which is there, and then 2 pi over 6, which reduces to pi over 3. Okay, this is going to be our phase shift. Don't forget to include the negative. It's always the opposite sign of whatever you have here. And then the period is going to be 2 pi over b, and b is going to be the number right next to that x. So in this case, it's going to just be pi. Okay. Number 11. Number 11, now we're given a graph. Let's go ahead and figure out how to find the equation. There's a couple of things you want to do for these because you're going to have multiple answers, or you could. I'm going to suggest starting with the top and the bottom, draw out your points. Okay. You know that A is going to be the distance from the center to the top, which in this case is going to be 3. Okay. X is equal to 0. Does it start at the bottom or the top? If so, you use cosine. If it starts in the center, we're going to use sine. Since this starts in the center and it's going in an up direction, there's no reflection. So I can say A is 3, positive 3, because there's no reflection. We're using the sine function. Next thing I want to do is go ahead and determine what the period is. Period starts at one point, and then when it reaches the next location, that's the length of the period. It's hard to tell, but the period here is 3 pi. So I put period is equal to 3 pi, and then put what the equation is equal to. Period is also equal to 2 pi over b. Solve for b. You should get b is equal to 2/3. Don't forget to put that right in front of your X. Okay? All right? Number 12. Number 12 is writing another graph. Okay, we're going to do the same thing. We're going to go ahead and draw the bottom of the line, the top of the line, and the center of the line. Here you can see the center is shifted up, so we have a vertical shift of +1. Okay, you can also see that your A is going to be the distance between the center and the top line, or the center and the bottom line. So in this case, there's a difference of 2, so A is going to be equal to 2. That's the 2 here. Okay. Now what you want to do is start at the 0 and then determine, does it start at the top, the center, or the bottom? Because it starts at the bottom, it means we're using the cosine function, and because it starts on the bottom, it will be a negative in front of that 2 because there is reflection. Okay. The last thing you need to do is determine what the B is. So I need to determine what the period is. So the period, I start at one point, normally at the origin, and then I figure out the distance until I get to that same point again. So these 2 points is one complete period, so the period here is going to be 6. So I put period is equal to 6, period is also equal to 2 pi over b, and I solve for b. Whatever you get for b goes right after the trig function and right before the x. Do not include parentheses on the 1, otherwise it would be wrong because it would be considering that as a phase shift. Okay, number 13, now we have a word problem. It says an object moves in simple harmonic motion with a period of 6 minutes. So here I put period is equal to 6. The amplitude is 15 meters. I put A is equal to 15. At a time of 0 minutes, its displacement from rest is 0. So in other words, if I were to draw this out, it's starting in the center at 0. So which trig function should we use that starts at the center? Well, hopefully you said sine. It says it initially moves in a negative direction, so that means it's going down. Okay, so that tells me there's a negative in front of that 15. So the 15 is our A. We're using sine because it's at 0, 0. And then it's going to tell us that the period is 6 minutes. So when we do our math here, 6 is equal to 2 pi over b. B has to equal to pi over 3. We're going to put the b here and then follow it with our variable t. Okay. And the last problem. This is probably one that is a little bit more frustrating because our notes didn't cover it. I don't know why Alex didn't cover it, but you need to know that the frequency is equal to 1 over p. This is also why I do one example or more of these types of problems because some of the notes do not include everything. Okay, all you're doing here is you're given a graph here. This is going to be a vertical shift. This is a negative. This is our A. This is our B. Okay, all we're going to do is figure out the frequency of the cycles, the population, and then one full cycle of the period, okay, in the years. All right, so here's our frequency is equal to 1 over p. First thing we need to know is what our B is, okay? When I'm looking at this, 1.5 is next to the t and after the sine function, so our B is 1.5. Period is going to be 2 pi over b, and I do this and I get approximately 4.19 years. Once I flip that into the calculator, using the calculator, I will get approximately 0.24 cycles per year. Okay, so frequency wasn't horrible. Let's go ahead and do the maximum population size. So the maximum population, remember this part is our vertical shift, and this is our A, so all you're going to do is add those two numbers together. Okay, it doesn't matter that this is negative. Remember, it goes down and then it goes up. We're going to go from the center, the shift, and add it. So our maximum population would be 4,340. Okay, that concludes this entire section. Let me know if you have any questions.